Hi, this is Geometric Sequences and Series again. This is part 3, and basically there's three subplots here. Basically, these problems here we want to identify whether the sequence is arithmetic, geometric, or neither. These are fairly simple problems, but you can do it a couple of ways. I'll show you those in a second. The example 4 and 5, we want to find the fifth term of the sequence. They tell you what the first term is and the common ratio. And we don't want to just list them out until you find it. We want to use a formula. And we also want to find the nth term formula for that. Now this one, we want to find the indicated term. So we want to look for the eighth term of this one. And again, I don't want you to just list them out until you get to the eighth term, and neither do I want you to do that on the 10th term on this one. We are going to be using the formulas to do that. So now let's look at these three examples over here. They want given a sequence as arithmetic, geometric, or neither. Which of the three is it? Now, there's an easy way to do this. The easiest way that I like is, well, is the sequence if it's arithmetic, then it's got to be linear in form. If it's geometric, then it's got to be exponential in form. The only way it's going to be neither if it's neither linear nor exponential. So remember, linears are going to be arithmetic, exponentials are going to be geometric, and if you don't have one of those two, then it's neither. That's, to me, is the easiest way. Another way to do it is list about 4 elements, or 4 terms, the first 4 terms, and look at those first four terms and see if the sequence appears to be arithmetic, if there's a common difference between the terms, or is there a common ratio between the terms. And if you don't have either one of those two, then it's got to be the neither one. So, but really to me, these are really simple because this one's linear, so it's arithmetic. This one's exponential because of the base of -1/2 to the n power, and so that one's going to be geometric, and that one's going to be neither because that's quadratic. And quadratics are very confusing for people because they think quadratics are exponential because they see an exponent. But this is an exponent. This is not an exponential problem. This is a quadratic function, and so quadratics would fall in the neither category. Okay, because it's not linear and it's not exponential. So to me, that's easier. I mean, this is going to be arithmetic. This one's going to be geometric, and this one's going to be neither. And I think the book, if I remember correctly, they're saying if it's arithmetic, then tell me what the common difference is. If it's geometric, identify what the common ratio is. So. Now, like I said, I'm going to do this the easy way. This one's a linear one, so it's going to be arithmetic. And since it's arithmetic, the common difference is, remember, the slope. So in this case, 5. So that's done. Now let me show you how you would do it if you're not sure about that. You would list out a few elements, put 1 in, that'll give you 4. Put 2 in, that'll give you 9. Put 3 in, that'll give you 14. Put 5 in, then you put 4 in, which is 5 times 4 is 20 minus 1 is 19. And then about 4 elements should be enough. And if you look, like there's a gap of 5 between each one of the numbers. 4 to 9, there's a gap of 5. From 9 to 14, there's a gap of 5. So, but again, that's to me is more difficult than just having to list them out. So it's just linear in form, so it's got to be arithmetic. So it's arithmetic with a common difference of 5. Now example 2, like I said, it's exponential, so it's geometric. So this one's geometric, and the ratio is -1/2 because remember the common ratio is the base, and 5 is not part of the base. It's just the -1/2. So so that answers that question. But again, you can list out 4 or 5 elements, and you're going to notice real fast that there is not a common gap between them. The gap actually gets smaller and smaller and smaller between them, and so it's not arithmetic. So you're hoping for geometric, and it is. It's geometric. So now the last one, like I said, it's quadratic in form, and quadratics fits that category that people get confused with exponential, so therefore they think it's geometric. And it's not geometric because this is not exponential. It's quadratic. So this one would fit in the neither category. And the neither category, you're done. There is no common ratio. There's no common difference. So that one's pretty much is what it is. So that's the first three examples, and this are the problems that you had to identify which sequence is what kind. So now the next problems is we're finding the fifth term and the nth term, and they're giving you the first term and the ratio. And like I said before, you could actually list these things out the old-fashioned way, and I really don't want you to do that. You've got to use the formula, and the formula is a sub n equals a sub 1 times r to the n minus 1. And that was a formula that one of the formulas that I gave you in part 1. So what you do, if you want the fifth term, you just plug 5 in for the n. So it's a sub 5 equals a sub 1, which you tell me is 5. R you tell me is negative 2, and then n minus 1 is 5 minus 1, which is 4. And if you don't know how to do that, just pull out your calculator to really be safe than sorry. But negative 2 to the 4th is 16, and 16 times 5 is 80. So 80 is the fifth term. And this is how I want to see it. I don't want to see what I'm about ready to show you. I don't want to see this. 5, negative 10, 20, negative 40, and then 80. So people list them out. 5, negative 10, 20, because r is negative 2. And then negative 2 times 20 is negative 40. And then negative 40 times negative 2 is 80. And then 1, 2, 3, 4, 5. And there it is. I don't want to see that. If you want to go to the side and check your answer to make sure your answer is right by doing that, but don't let me see it. I do not want to see that. If I don't see it, I don't know it. So if I don't know it, then there's no harm. So, but that's what I would call the 8th grade approach. Don't like seeing 8th grade approaches. You guys are 18, 19 years old at least. So I want to see it done the way we should be doing it. Okay, so the fifth term is 80. And then the formula, the nth term is just a formula. Just plug in what you know. So it's going to be 5 times negative 2 to the n minus 1. And you're like, what do you put in for n? You don't. That's the formula. So you just plug in 5 in for the first term, negative 2 in for the r, n minus 1 is the unknown, so there you have a formula. Now the biggest trap people fall in, some of you guys are probably seeing it right now, you want to do something with this. And I bet some of you guys are thinking, okay, the next step is negative 10 to the n minus 1. Because after all, 5 times negative 2 is negative 10. But you forgot PEMDAS. You forgot the please excuse my dear Aunt Sally, the order of operations, if you will. You cannot multiply 5 times negative 2 because that's multiplication. And exponents will override multiplication. So you've got to take care of negative 2 to the n minus 1 first and then multiply it by 5. But you can't do that either. So it is as it is. You don't do anything to it. Just leave it alone. So there's two answers to this problem. They want the fifth term and the nth term. Besides, like I said, I keep telling you guys in class, when you're in doubt, if something can be simplified, don't do it. If you're darn sure that it simplifies, go ahead and do it. But if there's a little bit of doubt, don't. I will count up 4 less points if you don't simplify something that can be simplified, as opposed to attempt to simplify something that can't be. If you do that, I will be brutal on points. So, now, example 5. Again, you use the same formula. A sub n equals a sub 1 times r to the n minus 1. So the fifth term is a sub 5 equals a sub 1, which is 16, times r, which is 1/2 to the 4th power. And pull out the calculator if you have to, but 1/2 to the 4th is 1/16. And then so it'll be 16 times 1/16, which is 1. So that's the fifth. That is the fifth term of the sequence, is 1. So, and again, you can do it by the 8th grade approach, but I want to see it. 16, 8, 4, 2, 1. I'm multiplying by 1/2 every time. Fifth term is 1. So yeah, it's a lot quicker. I know it's quicker if you're only finding 5 terms, but just imagine if I was asking you to find the 45th term. 45th term would be a lot more difficult to do it the way you're doing it. So that's why you do it. You've got to pretend that these terms are way out there. Now, the formula, just plug in what you know. A sub n equals a sub 1, which is 16 times 1/2 to the n minus 1. So the nth term formula is pretty easy. You just drop in two numbers into the formula and call it done. So, and no, it's not 8 to the n minus 1 for the same reason that was not negative 10 to the n minus 1. So that's this one, and that's that's the fifth term, which is 1. So anyway, so this is another subpart of this section, is looking for the fifth term and the nth term. Now, the last part of part 3, we're going to find the indicated term, which is really the same thing as these two examples. These two are actually a little bit easier than these two, because here you got to find two things, and here you're only finding one thing. And the only other difference is that they flat out tell you what R is on this problem. They do not on this problem. You have to actually find R yourself. They do kind of give you the first term, even though they don't tell you it's the first term. You just got to be able to recognize that as the first term, and that's 1. And this one is 128. So you do the same thing. It's a sub n equals a sub 1 times r to the n minus 1. And so since I'm looking for the 8th term, plug in 8 for the n. A sub 1 is 1. And then r is negative 1/2. And you're like, why is that negative 1/2? I know that because I got the second term and divided it by the first term. So that's how you find the r. And since that was a 1, then negative 1/2 divided by 1 is negative 1/2. But you're like, well, can you divide 1/4 by negative 1/2? You can if you like pain. 1/4 divided by negative 1/2 is negative 1/2. It's just not going to be easy to do. And it's a lot easier to divide this by this than the third term by the second term. So I always go the easy way out. So it's negative 1/2. There's the rate, the ratio, the common ratio. And then what number should that be? That should be 8 minus 1, which is 7. And I believe the final answer is negative 1 over 128. Negative 1 to the 7th is negative 1, and then 2 to the 7th is 2 times 2 times 2, 7 times 128, I believe. So that is the 8th term. And that's all. They're not asking you to find the nth term on this one. They just want you to find the 8th term on this one. And then finally, on this one here, 128, 64, 32, 16, you want to find the 10th term. So again, use this one. A sub n equals a sub 1 times r to the n minus 1. So the 10th term, 128 is the first term. R is, they don't tell you directly, but it is 1/2. 64 divided by 128. If those two numbers are too big for you to work with, divide 16 by 32. That might be a little helpful. So it's 1/2, and it's 1/2 to the 9th. So, and then you take 1/2 to the 9th. So it's going to be 128 times 1/2 to the 9th. Now 1 to the 9th is 1, and then 2 to the 9th, maybe 2048, I'm hoping. I have no idea. I think, maybe. I just made this problem up before I put it on the board. No, it's 2 to the 9th is 512. So it's 512. Yeah, that's right. So, and then 128 divided by 512 is actually, I believe, 1/4. So it's going to be 128 over 512. Yeah, that's right. May take you a little bit of time to actually reduce that down, but I believe, pretty sure it's 1/4. So that is the 10th term of the sequence. And some people will get the right answer on these problems, on these exams, and they're expecting full credit. But I'm telling you, if you do it by the 8th grade approach, you will miss it. You will not be given anything. I will need to see the formula. I will need to see you show me how the formula works. This is not just getting the correct answer and going on. It's actually the way to get the answer is what we're looking for. So we don't look. I mean, we know you can actually list these things out. There's no challenge in that. Like I said, that would be a problem that an 8th grader could do, or below that. So But I don't want you to just be listing them out, the 16, then the 8, then the 4, and then keep going down until you get down to the 1/4. That's not the way we do it. So be careful with those. So some people will be strongly disappointed on the exam. They get on the exam, they get the right answer, and they think, oh, I got my 6 points. Well, no, you didn't. Not unless you show me using the formula. So be very careful with that. So this is 9.3, part 3. I got 2 more parts coming up, so stay tuned.